Hey guys, here are a couple more examples like the ones we did in class today, just to give you a little more reference in case you're having trouble with your homework. Somebody had emailed asking for this, so hopefully this will help. Let's see, it looks like most of this was labeled for us. The 18 I added in myself. They gave us that CD is 18, so actually it's this piece here is 18. Okay, 18 is there. Alright, so let's just start from the beginning and see what we can get. The first thing they're asking for is BD. Well, BD is right here. Well, they're telling us that G is the centroid, and we know the centroid is made up of all the medians of a triangle. And we, of course, know that medians go from a vertex to the midpoint of the opposite side. So that means these two pieces are the same, these two pieces are the same, and these two pieces are the same. So if D is the midpoint, E is the midpoint, F is the midpoint, we get all these pieces to match up. Now that doesn't mean all these pieces are the same, to each other. It just means that each pair have to be the same. These two have to be the same. Those two have to be the same, etc. So if this piece is 8, well then this piece has to be 8, and that takes care of your first unknown. Alright? AB. AB is located, okay, so that's the whole thing, right? So once you get this one, you got to realize, okay, I guess 8 plus 8, that gives us the total. That's 16, no big deal. Okay? And I noticed also these have the segment tick mark on top, which sort of implies that we're not looking for the distance, we're looking for the length. So really, technically, it'd be the measure of that segment is 8. The measure of this segment is 16, but it's not a big deal. How about EG? Alright, now we're getting into some interesting stuff here. EG is just this little piece of the median from A to E. So what we learned today was there's a definite relationship between the pieces of the median of a triangle. And the one piece they gave us is this one, which is 10. And depending on which class you're in, hopefully you were able to tell that this little piece here is exactly half of the bigger piece. Now, not the whole thing. Right? If you look at the theorem, it talks about this part right here being 2/3 of the whole thing, or you can look at it as this piece is just twice as big as this piece. So if this piece is 10, well then this little piece here has to be 5. So that would be 5. Now again, you could double check. 10 is 2/3 of the whole thing, which is 15. That makes sense. And 5 is 1/3 of the whole thing, which was 15, which makes sense. So EG is exactly half of AG. How about AE? Let's see, AE is next. Where's AE? Oh, well, that's okay. Now they want the whole thing. So that's a little easier. Once you, of course, get the smaller pieces, it's easy to get the bigger piece. CG. Let's see, CG is here. Okay, so here's where we know that 18 is the entire piece, right? 18 is the entire piece from C to D, but I only want from C to G. Well, again, we're breaking this up into thirds. This is a third. This is 2/3. So if I break 18 up into thirds, well, that would be 6, 6, and 6, right? So 6, and then this would have to be 6 and 6, which is 12, because this piece is exactly twice as big as this piece. So if this piece is 6, this piece is 12. That didn't come out so good, but it's 12, which is here. Oops, sorry, this one, 12. Okay? Yeah, sorry about that. I got a little smudged. 12. There we go, that's okay. And of course, 12 plus 6 is 18, so you know you did it right. So it's not, again, when you get the 18, don't just assume you're like splitting in half, right? It's not going to be 9 and 9 because of the theorem. The theorem says that this piece has to be 2/3 the length of the whole thing. Alright, and what we determined was it's a little easier to just use that this piece is exactly double this little piece. And then DG, where's DG? DG goes from here to here. We already kind of got it now. We got that to be 6. We sort of use that to help us in the whole thing. Doesn't really matter which ones you get first, but those are all the pieces of the puzzle. Okay, hopefully that helped with this kind of problem. Try to just break it down to one little piece at a time. If it helps, you could always trace the triangle and then just copy the one piece you want. For instance, if you're dealing with a triangle that has a median here, you could just focus your attention on that one median, and maybe your centroid is located somewhere over here. And it might be easier if this was 18, right? If you knew this was 18, well then this would be 6 and this would be 12, and you'd be good to go. All right, let's try another one, a different type of problem. Let's look at the one on the grid. Okay, The first thing it says to do is find the coordinates of M, which is the midpoint of JK. So if this is JK, we got to find the midpoint using the midpoint formula. So the midpoint is going to be x1 plus x2 divided by 2, and y1 plus y2 divided by 2. And that's going to be, what, 2 comma 4. Let's see, 2, 2, 4. So it looks like it's right here. That kind of makes sense. So this is going to be M, which is located at 2, 4. Now all we did there was a midpoint. We didn't do anything fancy. If you have trouble with the midpoint formula, they do, they give you an example on the other page, I believe. Where is it? Not there, sorry. Here it is. Okay, they do one out for you where they use the midpoint formula right here to figure out. So if you want to go back to this example, if you want to review this type of problem, there's another place you could go. But I'm just going to finish this one up for practice. And what's the next thing it says? Use the median LM, okay, so that's this one, to find the coordinates of the centroid P. So again, we need to go 2/3 of the way from the vertex, or 1/3 away from the midpoint, whichever way is easier, to actually get this centroid. So I really need to know the entire length first, just like we did on the problems up here. If we knew the entire length, we could figure out the length of each piece. So they did this on purpose because the median is vertical. We can just count, right? These go up by 2. So where are we here? -5. So we go up 1, 3, 5, 7, 9. Looks like this is 9 units long. It goes from -5 to +4, which is 9 units long. So this entire piece is 9 units. Well, if I'm going to break that up into thirds, I have 3, 3, and 3. So my centroid is going to be 3 units away from M, or 6 units away from L, whichever way you want to look at it. So 3 units away from M would be 2, 3 would be here. 6 units away from L, 1, 3, 5, 6. 6 units away there. So this would be 6 and this would be 3. And the coordinates of that point look like it's at 2, 1. 2, 1, which is P. Okay? Double check. To go from 4 down to 1, I'd have to subtract 3, so I'd be 3 units long there. To go from -5 up to 1, I'd have to go up 6 units, which is exactly 2/3 of the full 9 that make up the median. And that's how you do that kind. Some of them on the homework I think also went horizontally. That's fine. It's the same idea. Really, honestly, it's really no different than doing this problem here. Okay, it just would be horizontal instead of vertical. It's the same concept. Find the length of the median, and then either go 1/3 from the midpoint or 2/3 from the vertex. And if it's not horizontal or vertical, try a different median. Okay, this one they told you exactly which one to do, but if they give you a different one, try a different median. And then the last one here is find the coordinates of N, which is the midpoint of JL. Let's see, where's N? So JL is here, so N is going to be -2 plus 2 is -2 plus 2 over 2. And 7 plus -5 over 2 is, that's 0, comma, what's that, 1. So 0, 1 is the midpoint, 1, and that's N. And they said to verify that KP is 2/3 KN. So KP is right here. And they want you to, I'm sorry, P is here. KP is this part, and they want you to verify that it's 2/3. So how far is it from 6, 1 to 0, 1? Right? From 6, 1 to 0, 1, it looks like we had to go over 6 full units, right? So 2/3 of 6 units would be 4 units. And is it 4 units across? 2, 4. Same thing. Same thing. KP was 6. I'm sorry. KP was 4. K to P was 4, and that's 2/3 times KN, which was 6. And that is correct. They're both 4. That's how you could check it. So this problem actually gives you a vertical median to play around with and a horizontal median to play around with, and in both cases you get to use the same theorem. Okay, these can get a little tricky just because you're dealing with coordinates, and it doesn't help that they're going up by 2's, but that's the idea. Alright, again, all of them revolve around the same main concept of using the length of the median to figure out the length of each individual little piece. Alright, so hopefully that helps with your homework. Obviously, if you have any other questions, feel free to ask, and I will see you guys. I'll see you guys later. Okay, bye.